On our previous video, we classified numbers as the following. We classified one particular category as small numbers, where we are looking at numbers that are between -1 and +1 on a number line, while on the other hand, we looked at large numbers, which are numbers that are found on a number line, and these numbers are indeed values that are either greater than 1 or less than -1, as shown on a number line. So in here we have +1, and you're looking at this area to positive infinity, while on the other hand we have -1 to bigger negative values, as shown right here from -1. So in here in this video, we're going to apply this logic to these particular questions that are in this box, and what we're going to do is classify each numbers as shown here either as small numbers or large numbers. This here has a mix of two types of numbers. We have one type of number that is known to be written as the following. It is written as either standard form or notation, and while on the other hand we have types of numbers that are written as what? Scientific notation. And so for standard form, in this particular question bank that we have here in terms of numbers, we have the following to be identified. We have this to be written as standard form, we have this to be written as standard form, another one here is written this as standard form, and finally we have this to be written as standard form, while the others that are shown here are written as scientific notation. And you might be asking yourself, why is this the case? We're going to talk about this on our next video in terms of how we classify one as standard and the other as scientific notation and the advantages of both of them. Now in this video, we need to see how we can transform one type of number to another type of number, which is from standard form to scientific form, and be able to address them as small numbers and large numbers. But the short way of doing this here in this video is by looking at it in this video. If, for example, for your scientific notation as shown right here, if you have a negative exponent for your power 10, then it means that it is classified automatically as a small number. So this here is indeed a small number. And another one here to look at is that yes, we have all other numbers that are shown here to not have powers of 10, that is the exponents to be a negative value. However, we do have decimals that have a 0 as the whole number, and so once we have this, we can now go ahead and classify this here either negative value as small number, because so 0 is the only number that is before the decimal point. If you have a 1 before that 0, automatically it is a large number. So that is something to keep in mind. This one as well has a 0 before the decimal point only, and this is automatically classified as a small number. Next here is what? The rest. The rest here, this either written in this case as standard form, it has a 1 and we have zeros, no decimal point. This here is going to be written, if you want it as scientific notation, to be what? Scientific notation is going to be written as 1.0 times 10 to the power of 1, 2, 3, 4 and to the power of 4. And so that is your scientific notation for the standard form. Next here is this right here. If you change this to scientific notation, we have 3.215 times 10 to the power of what? We have 1, 2, 3, 4, 5, 6, 6 to the power of 6, and that is it. So in conclusion, large numbers have their exponents of that power of 10 to be what? Greater than 0. So if you have or equal to 0, so in this case this here is considered to be a large number because this 10 here, its exponent, it is a 0, and this can be written in standard form. And you write this in standard form, it is the same thing as what? It is the same thing as 4.34. And we can prove this by transforming this to a whole number, and we're going to do that in our future videos. The other ones here, like for example, this negative value is really large, and so this is automatically a large number. Another one here, which is 5.01 times 10 to the power of 2. We have our exponent here of our 10 to be 2, positive value, automatically is a large number. This here has the 10's exponent to be a positive value, which is 6. It is classified as a large number. And finally, this here is classified as a large number because our 10's exponent is 4, which is a positive value. So I hope you found this really informative in terms of classifying small numbers and large numbers given these particular questions. I encourage you to look at the following. If you have your exponent of your power of 10 to be a negative, not a positive, a negative, keep that in mind, number, then it means that it is classified as a small number. However, if you have your exponent of a power of 10 to be positive, then it is considered to be a large number, like what we have right here, including 0, like what we have right here, right here, right here, and right there. The negative sign that you see in front of your number doesn't make it to be a negative number, because this negative sign is for the whole quantity of this particular value, which is indeed a large number here. Likewise, for this right here, this negative sign is the quantity of how small, in this case 0.01 is. I hope you find this really informative. Hit a comment down below, let me hear your thoughts about this, but that way I can talk to you soon. Stay smart as always and believe in yourselves.